Alrighty, greetings folks, and welcome to Math 10 all over again. That's right, you thought it was over, but it's not. We're going to be looking really quickly here at a review of the sine, cosine, and tangent ratios, and looking starting with a tangent ratio just because it's the easiest one to do for no other reason besides that. And you'll see there that I have three similar triangles, and they're similar because they all have the same angles. That is, they all have this right angle there, okay? And they all share this common angle there. So therefore, all three angles have to be the same. In other words, this angle, and that angle has to be the same just by third angle of a triangle theorem. So all have the same angles, therefore they're all similar. Okay, and I have some dimensions there that are not to scale, but don't worry about it. And we can work out the ratio of various sides. In other words, if I take the opposite side, looking at, again, still this angle here, okay, the opposite side to that angle there is 3. Let me just move this down a little bit here. The opposite side is 3, and the adjacent side is equal to 4. Okay, so that ratio, opposite over adjacent, is equal to 3 over 4. And the same thing for the larger triangle, 6 over 8, which is the same as 9 over 12. Okay, and those all equal 0.75. Okay, and that is the same ratio of for any triangle, and that is a right triangle that has that same ratio corresponding sides. This is going to be the same for any triangle with that same angle here, whatever that angle is. Okay. It just so happens that that angle there is actually equal to 36.87 degrees, and I only know that because I calculated it. But that's the angle there, and so the tangent ratio is said to the tangent ratio for any angle. We used a Greek letter that looks like an O that you just kind of kept going too far with, called a theta. If you're Mrs. Jones, you'd say theta. Anyways, we're not. So the angle is, for any angle, the tangent ratio is always going to equal the opposite side to the adjacent side. Okay, opposite over adjacent. And for the angle 36.87 degrees, if on your calculator you were to actually put this into your calculator and try it, tan 36.87 would in fact equal 0.75. That means that any triangle that has that angle 36.87 degrees, okay, the tangent ratio will always be 0.75, which is why when you put in your calculator tan 36.87, you will always get 0.75. Okay, that's kind of an obscure angle though. Let's look at maybe a more common angle and see if we can look at a tangent ratio for that one. Okay, so here we have a 30, 60, 90 triangle, and the sides opposite, adjacent, hypotenuse are all relative, well, except for hypotenuse, which is always the same. And the hypotenuse is always the longest side, or the side opposite the 90-degree angle. So here's my 90-degree angle, and this side over here is the hypotenuse, always. Okay, and then depending which angle I'm talking about, let's talk about the 60-degree angle over here. The opposite side is a side that I always imagine this is like a little eyeball, a creepy little eyeball, okay, and it's staring across the way like a peeping Tom, and that makes this my opposite side, and this my, whoops, the adjacent side, the side that is next to the 60-degree angle that is not the hypotenuse, okay? And of course, that would change if I was looking at the 30-degree angle. And if I was looking at the 30-degree angle, then this would be the opposite side, okay? Anyways, so what I want you to do right now is I want you to pause the video and with a calculator, just figure out what is the tangent ratio for 60 degrees. Just plug it into your calculator, and I'll give you 3 seconds. Do now. Tangent of 60. Okay, so the tangent of 60 is equal to 1.73, a weird little number, but in the next video I'm going to show you how that number is significant and how we get it using a little bit of Pythagoras theorem. So let's have a look at that video now.